Let's look at a few examples here with our SAS and HL congruence theorems. And we will also sometimes see SSS as well. So we're just going to keep adding to the list. So these first four examples are not necessarily official two-column proofs, but we are going to write out many elements within a two-column proof so that when we get to those proofs, they are a little easier to work with. So the directions say, decide whether enough information is given to prove that the triangles are congruent using the SAS congruence postulate or HL. So we're going to just focus on those two right here. And so we're going to look for, if we're doing SAS, do we have two sides and the included angle? Or if it's HL, we have a right triangle, a hypotenuse, and the corresponding leg. So number one, we're looking at triangles PQT and RQS. So let's list what we see here. So I'm going to start with the first marks. So I see that TQ is congruent to SQ, okay, and that's just given to us. I see the double marks. I see that PQ is congruent to segment RQ. And then I'm also given this angle right here. And so that is angle PQT. It is congruent to angle RQT. So all of it's given to us. So the question is, do we have enough information to prove them congruent? And so we do. In fact, because this angle right here is the included angle in between the two sides, we can use SAS. So I'm just going to go ahead and finish this up and say triangle PQT is congruent to triangle RQT by SAS. So what I wrote out is really what you need to go through in your mind to make sure that you have everything you need. And in fact, if I needed to do a proof right here, I just basically wrote everything out I needed except the given. Okay, second one. I see a set of sides. So I see that segment NK is congruent to segment LK. And then I've got another set here, the double marks. Segment JK is congruent to segment MK. Okay, those are just given. As you do this, though, are there things in the picture that you know are true based on prior theorems, properties, definitions, and things like that? So I see something else that isn't marked that is congruent. I see this angle on the left and this angle on the right. I see vertical angles. So I want to include that in my decision on whether the triangles are congruent. So I see that angle JKN is congruent to angle MKL. And I'm just going to make a note over here that these are vertical angles. Okay, because we're not doing a formal proof here, but these are things you need to find. So that being said, I have SAS. That vertical angle is included. So I know that triangle JKN is congruent to triangle, it doesn't matter how you name, I guess it does matter how you name this here. So it should be named MKL, because I'm trying to align my corresponding sides, by SAS. Oops, I'm writing that backwards. SAS. SAS. Okay. One other comment too when I'm naming these angles on the vertical angles line. The vertex of the angle must be the middle letter. So when I started with JKN, I could have started with NKJ as long as K is in the middle there. Okay, let's look at number 3. All right, I'm going to kind of write and mark as I go. So AB is congruent to DC. Okay, so I have a side that's given to me. AB is congruent to DC. I have a right angle. BA is perpendicular to AC, oops, and CD is perpendicular to DB. So I'm not necessarily going to write that down because I'm trying to see, I'm just wanting to identify the side, the angle, and the side, if it's side, angle, side, or the hypotenuse and the leg if it's HL. Okay, can I show the triangles are congruent? Okay, let's come back to A and D. I have a reflexive. Okay, I'm going to mark BC. So BC is in both triangles. So I'm going to write that down. BC is congruent to BC, and that is reflexive. Okay, I have HL right here. I have hypotenuse leg. Now, the reflexive is the hypotenuse, and then AB and CD is the corresponding leg. Now, the other thing I'm going to write down here, though, that is an underlying condition of HL is, do I have right triangles? And so because of the right angles here, I do have right triangles. Okay, so I'm going to write down next. I'm going to write that triangle ABC and triangle DCB are right triangles. And so now I really have three conditions with HL. I have a hypotenuse, a leg, and a right triangle. Okay, so I've got my hypotenuse here with the reflexive. I have a leg, and then I have the right triangles. So I now can show that triangle ABC is congruent to triangle DCB by HL. Okay, last one, number 4 down here. Okay, I have two sides and I have an angle. So I'm just going to mark a few things here. And I see reflexive. Okay, I'm going to go like that. So this, though, is looking a little off. Because if you look at WY and ZY, so those are not corresponding sides. And so if I look at these names right here, WY, first and last letter, and ZY, well, actually, let me back up a second here. It doesn't exactly tell us if they're corresponding sides because this is not necessarily a congruent statement. So I'm going to say here, not congruent statement. The one thing, though, that is a little off is, I'm going to just highlight right here in this triangle. So I do have two sides and the included angle in this triangle. But if you look at the other triangle, let me not use my highlighter here. Let me use another color. If I had the included angle, it should be right here. And so because it's not sandwiched in between the two sides, because it's up here, it's not the correct corresponding angle. So I'm going to say here, not congruent. And then we are going to say here, I'm going to add not included angle. Okay. So, and the picture should look a little off to you, but we want to really make sure that the correct angle is provided. All right, so we did just sort of an informal layout of identifying potentially SAS and HL. Okay, let's actually now do some full proofs. Okay, number 5. So go ahead, let's get our T-chart set up. So label your columns. You've got statements and reasons. And then again, I'm going to go ahead and just put both givens in line 1. And then looks like A, B, and DB are marked already. BC is perpendicular to AD. So I'm going to add the right angle there. Okay, so from here, you can go one of two ways. You can make a statement off the given, or you can look at your diagram to see if anything jumps out at you that is also congruent. So I am trying to prove that triangle ABC, the triangle on the left, is congruent to the triangle on the right. So one thing that jumps out at me is I have a reflexive segment. So I'm going to go ahead and mark that and write that down. So I'm going to write down segment BC is congruent to segment BC. And that's our reflexive property of congruence. Okay. Okay. Now, thinking ahead to SAS. Do I think I can get to SAS? So I know here, I'm going to mark a little and then do some erasing. I know that these two angles are both 90. And I know two 90-degree angles are the same. But those two angles will not give me SAS because it's not the included angle. So I can't really go in that route. But I actually do have HL here. So I have condition number 1, right triangle. Condition number 2, the blue tick marks are the hypotenuse and the reflexive is the leg. Now, I do need one more line in here because I haven't really stated that. How do I know this is a right triangle? Well, I know this is a right triangle because I know what it means to have perpendicular lines. I know that perpendicular lines make right angles. And then I also know that if you have a right angle, you have a right triangle. So I actually need 2 lines in here to say that. So I need to first say that I know that I have a right angle. So I'm going to say here that angle BCA and angle BCD are right angles. And I know that because I know what the definition of perpendicular lines are. So this is going to be definition of perpendicular lines. Okay. Then I need to say, well, if those are right angles, then that means I have right triangles. So I'm going to say here that triangle BCA and triangle BCD are right triangles. And then this is another definition. So because I established that I had right angles, the definition of a right triangle is having one right angle. So definition of right triangles. Okay, now I'm ready to finish. I see I've got my hypotenuse, my leg. I've established I have right triangles. So now I'm ready to end. So we recopy the prove line. So triangle ABC is congruent to triangle DBC. And I have just demonstrated HL. So oftentimes, when we're working with HL, actually maybe I won't highlight. Let me just kind of over to the side outline. Oftentimes when we're working with HL, I need these 2 lines together. So if I don't have in the given that I'm given right triangles, I need to establish that they're there. Okay, one more, number 6. Go ahead and get that one set up. You might pause the video till you get everything set up. You actually might go ahead and see how far you can get here, but I'm going to go ahead and get my T-chart drawn. Okay, one thing that I want you to pay attention to is what we're trying to prove. So we are trying to prove, I'm going to outline as I talk, JKL, triangle JKL, so that's this triangle in red, is congruent to triangle MLK, MLK. So do you see how they overlap each other? So sometimes when triangles overlap, it's a little hard to tell what triangle is what. So what I like to do is I like to resketch them as if I'm pulling them apart. So that, what I mean by that is, if I draw the top one here, so JKL, and then this one here is KLM. And then a lot of times I will relabel my markings. So this was a 90 and this is a 90. And then this saying KJ is congruent to LM. Okay, so sometimes it's easier to see when they're separated out, but sometimes I also need the original picture as well. Okay, so I am trying to go for, do I have side, side, side? Do I have SAS? Maybe I have HL. Okay, I've got the 90s, so I have a right triangle here. I can say that if I need it. I have one equal side. So KJ is a leg. If I'm going to go for HL, that means I need to figure out how to get JL and KM equal. And I don't know that there's really any theorem that will allow me to do that. I do want you to notice one side. I'm going to highlight KL. So do you see how KL is in this triangle and this triangle? Do you see how it's the exact same segment? So when I push those triangles back together, they overlap. So this is another example of reflexive. So because it's the exact same side in both triangles, it's a reflexive side. So I'm going to mark it and use that in my proof. So number 2, I'm going to say that segment KL is congruent to segment KL. That is our reflexive property of congruence. And then that right there gives me enough to have SAS. Now, because I am told that the angles are equal in the given, that they're both equal to each other, that gives me the angle. It is the included angle, okay, so I'm good to go there. So I'm ready to wrap up my proof. I'm ready to recopy the prove line. Triangle JKL is congruent to triangle MLK, and that is by SAS. Okay. I would like you to finish up the bottom, and you are writing out either SAS, SSS, or HL on these triangles to determine if they're congruent. Now remember, if you see a reflexive, mark it. Use that in your decision making on which of the 3, or none. None is a valid answer as you go through this. So pause the video as you do that. Okay, letter A is side angle side. I'm going to mark reflexive. This is also side angle side. This is none. We don't have an angle, angle, angle. That does not guarantee congruence. Mark reflexive, and that now gives me HL because I can see the right triangles. Mark your vertical angles. That gives me SAS. Mark reflexive, and that gives me nothing. The angle is not included, so that does not guarantee congruence. Mark your reflexive, side, side, side. Okay, I think you could have a couple potential answers here maybe. Let's see. If I mark these alternate interior angles, that gives me side angle side. What about, I see vertical. I don't know if that's going to help me. It'll help me with something we haven't talked about yet, so I'm going to back off of vertical. I also want to point out that if I mark this alternate interior angle on this side, I don't have side angle side. So it's got to be the ones I marked in red. And then the last one, I'm going to mark my reflexive. This is SAS, not HL, because I don't have the hypotenuse. Okay, that wraps up SAS and HL for today.